From stars that are cold enough to touch with your hand, to the fact that Jupiter is technically our sun's failed twin, there is a virtually endless list of intriguing facts about our universe. New discoveries are being made on an almost weekly basis. And if you thought you understood how our cosmos works, chances are you didn't. Even our biggest minds struggle to wrap their heads around what's really going on, and as hypotheses are developed to answer some of the questions, new unsolved mysteries are added to an ever-growing list. The truth is that reality is more fantastical than most dare imagine, and there's no better way to see this for yourself than to simply look into a telescope and try and make sense of it all. With that being said, what we do know about the universe is already enough to blow your mind, or at least make you question everything you thought you knew. So, these are 100 facts about space that are going to shock you. Just before we continue, a word from our lovely sponsor, Incogni. Look, you can try to disappear from the internet yourself, or you can just send someone a link and, let them do it for you. And that's where today's sponsor, Incogni, comes in. Look, if you've ever Googled yourself and found your full name, address, phone number on some shady site that you definitely didn't give it to, well, that's not just chance, is it? That's your data being bought, sold, and republished over and over. Incogni's custom removals lets you point to any site exposing your info and they'll work to get it taken down, even if it's not one of their 250 plus data brokers they already cover. It's simple. You paste the link, you hit submit, and their privacy experts take care of the rest. No templates, no legal threats, no back and forth. It's all very easy. It takes a few weeks and all that information is gone. So take your personal data back with Incogni. Use the code Sideprojects at incogni.com/sideprojects to get 60% off an annual plan. And now back to today's episode. Number 1. Starting off near home, the Earth fits into the Sun about 1 million times, and our Sun isn't even a particularly big star. The biggest star that we know of is UY Scuti, located about 9,500 light-years from Earth. UY Scuti's around 1,700 times larger than the Sun. Holy shit. And if it took the place of our Sun, its outer layers would engulf the solar system up to Jupiter. To put it another way, the Sun fits into UY Scuti around 5 billion times, and it's almost certain that there are bigger stars out there. Number 2. For most of human history, our brightest minds were convinced that liquid water was rare in the universe, and that Earth was the only planet in our solar system where it could be found. This perception is changing in recent years, with there now being growing evidence that liquid water was abundant on the surface of Mars and may still be present below the surface. Number 3. Expanding on this, Jupiter's moons, Europa, Ganymede, and Callisto, plus 2 of Saturn's moons, Enceladus and Titan, may be so abundant with water that Earth actually has a small amount by comparison. It's estimated that Europa may have as much as twice the water of all our oceans combined. Number 4. If you're still not convinced, a black hole was discovered at the center of a quasar located about 12 billion light-years from Earth, and an estimation says that the area around the black hole may contain enough water vapor to equal roughly 140 trillion times the water of all our oceans combined. Trillion with a T. That's 1,000 billion, by the way, which in itself is 1,000 million, which is in itself a lot. The water vapor is thought to have existed just 1.6 billion years after the Big Bang, making this the oldest and largest collection of water that we currently know about. Number 5. Let's turn our attention back to our own solar system, though. You can't land or walk on Jupiter, Saturn, Uranus, or Neptune since they don't have solid surfaces. It's often misunderstood that this means you'd sink into the poorly defined surface if you attempted to make contact. This doesn't mean you could simply fly through a gas planet, since the deeper layers of gas behave more like liquid, and the core layers are something close to being solid. But if you attempted to stand on the surface, you would sink in and probably be dead in seconds from the incredible amount of pressure and the intense radiation. So don't go to Jupiter. Number 6. Let's take this a step further. Saturn's average density is just 0.7 grams per cubic centimeter, while water has a density of 1 gram per cubic centimeter. This means that Saturn would technically float in water, though that's according to basic physics. What would really happen is that gases would interact with the water, cause an exothermic chemical reaction, the water would vaporize, and bizarrely, the enormous new cloud of water vapor would form a secondary gas giant, which is cool. Number 7. Sticking with Saturn for just a moment longer, the gas giant is known for its spectacular rings, which stretch out around the planet for around 140,000 kilometers from the equator. The rings are made of ice and rock, with each chunk ranging between the size of dust to giant boulders. One of the rings of Saturn's most unusual features is that it's absurdly thin in context, just a few hundred meters at most. To put this into context, if you wanted to match this scale with a Blu-ray disc, which is 120 millimeters wide and 1.2 millimeters thick, you'd need a disc about a kilometer wide. Number 8. If you wanted to fly to Saturn and check out the rings for yourself, you would want to try and do so in NASA's experimental unmanned plane, the X-43A, which has a top speed of Mach 9.6 or 10,600 kilometers an hour. At a constant top speed from the surface of the Earth to Saturn, not taking into account any complications and using Saturn's average distance from Earth, it would take you nearly 14 years. If you prefer a manned plane that you could actually fit inside, you'd want Lockheed's SR-71 Blackbird. Blackbird's top speed of 3,500 kilometers an hour using the same average distance, it would take around 46 years. Number 9. One complication that you'd want to take into account when leaving Earth's atmosphere is space junk, referring to anything man-made in orbit around the Earth that no longer serves a purpose. This includes non-functional satellites, leftovers from space station activities, and various other odds and ends. As of right now, it's estimated that there are around 500,000 pieces of space junk, and that number climbs by around 3,000 pieces every year. Though 200 to 400 space junk objects also re-enter the atmosphere annually, most of which burns up before it hits the ground. Number 10. Speaking of objects that mostly burn up in the atmosphere before they do any damage, an asteroid around 60 to 90 kilometers wide would be enough to totally obliterate all life on Earth. The Tunguska event, which saw 80 million trees flattened in Russia in 1908, was likely caused by an asteroid just 50 to 60 meters in diameter. Number 11. The Chelyabinsk event in 2013, which saw 1,000 people injured and 7,000 buildings damaged, was a meteor approximately 20 meters in diameter. It's all but certain that another similar event will happen sooner rather than later, and there's no telling where it will occur, given that the objects are too small to accurately track. Number 12. On the other end of the spectrum, there are asteroids so big as to have their own rings and moons. Chariklo is an asteroid with an unusual orbit positioned between Saturn and Uranus. It's 250 kilometers wide and is notable for having its own rings, putting it in the rare Centaur class. It's the smallest known object in the solar system to have its own rings. So good for it. Number 13. Chariklo pales in comparison to Ida and Dactyl, which were observed by NASA's Galileo spacecraft in 1993. Dactyl is a moon that orbits Ida, which sits in an orbit between Mars and Jupiter. Ida has an average diameter of 31.4 kilometers. Number 14. As impressive as Ida is, what it doesn't have is the tallest mountain currently known to exist. That accolade goes to Vesta, which also sits in orbit between Mars and Jupiter. Vesta has an average diameter of 525 kilometers and is home to a mountain 22 kilometers high. Vesta still isn't the biggest asteroid we know about by a long shot, though, because number 15. The record for that officially goes to the dwarf planet Ceres, which has now been classified as an asteroid, though was initially thought to be a new planet. Ceres also happens to be in the asteroid belt between Mars and Jupiter, and it has a diameter of 946 kilometers. Number 16. By the way, did you know that NASA's Dawn spacecraft visited Vesta in 2011 and spent a year investigating it? After Dawn left in 2012, it headed to its final destination, which happened to be Ceres. Number 17. Asteroids are certainly spectacular and are unquestionably dangerous on the rare occasion they fall to Earth and are big enough to not entirely burn up. But they aren't the only cosmic visitors we get on a regular basis. Other regular visitor is space dust, and you probably didn't know that it coats just about everything. 5,200 tons of space dust falls to Earth every year, invisible to the naked eye, consisting mostly of metal and rock particles that flake off asteroids and comets. To be precise, around 100 tons of dust falls to Earth a week, or 14 tons a day. It's almost certain that you've had some on you and didn't even know about it. Number 18. On the topic of small particles, there are an estimated 5 to 10 sextillion grains of sand on every beach on Earth combined. That doesn't even come close to the number of stars in the universe, which is a grand total of around 1 septillion. That's a 1, followed by 24 zeros, although that number is just a rough estimate based on what we can see from Earth. There may be many, many more. Number 19. Sunsets on Mars appear blue. This is because the atmosphere contains fine reddish dust that scatters red light, but allows blue light to pass through. On Earth, the opposite is true. Blue light is scattered and red light passes through more efficiently, giving us our spectacular sunsets. Number 20. Those red particles in the Martian atmosphere are rust, by the way, which is an interesting thing given that rust forms via oxidation, or in the case of Mars, by iron coming into contact with water and oxygen. This strongly suggests that there was an abundance of water on Mars, as we mentioned earlier. Number 21. Closer to home, back in our own neighborhood, we've got the moon, which isn't actually round, no matter what your eyes tell you. The moon is actually shaped like a lemon, with flattened poles and bulges around the equator. If you're wondering why the moon is that shape, so's everyone else. Current tidal bulging accounts for some of the unusual shape, but speculation is that the moon solidified when it was half the distance that it currently is from Earth, and retained the shape it originally formed with. Number 22. The current distance between Earth and the Moon is 400,000 kilometers, and in cosmic terms, that barely equates to a stone's throw. But if you took every other planet in the solar system and lined them up between Earth and the Moon, you'd fit every planet in the gap without too much of a squeeze. Number 23. Taking up most of that gap would be Jupiter, the largest planet in the solar system by far. Rather than lining up the planets side by side between the Earth and the Moon, you could put every planet inside Jupiter and still have 30% of the total space left over. Number 24. Put another way, Jupiter is known for its Great Red Spot located below the equator, and that spot happens to be a storm that rotates once every 6 days. The Great Red Spot is 1.3 times wider than Earth, translating to about 16,000 kilometers across. We're only seeing the fun-size version of the storm today, though, since it was much larger in the 19th century, about 48,000 kilometers. Number 25. Another lesser-known fact about Jupiter is that it's technically a failed star. Jupiter is also made up of hydrogen and helium, making it something of a sun twin. Jupiter, however, didn't ever start the nuclear fusion process, given that it's too small. Were it around 80 times larger, we'd have another sun in the solar system, which would be quite intense. Number 26. Getting back to the moon, our cosmic neighbor is getting further away, as suggested by the explanation for its lemon shape. Every year, the moon spirals outward by about 3.8 centimeters. Estimations are that the moon was 60,000 kilometers away 2.46 billion years ago, keeping in mind that it's 400,000 kilometers away today. Number 27. So it's a good thing the moon is the exact distance it is from Earth right now, because the equation just so happens to create the incredible solar eclipses that we witness. Solar eclipses occur, as they do, with the moon perfectly covering the sun by sheer coincidence. The sun is almost exactly 400 times bigger than the moon, and the sun is almost exactly 400 times further away. There is no rational reason or explanation for this, and there is no other known example of this anywhere in the known universe. As the moon gets further away, solar eclipses will no longer be as perfectly aligned as they are right now. Number 28. You can drink away the woes of a less perfectly aligned solar system if only you can get to the cloud discovered in 2009 at the center of the Milky Way. Called Sagittarius B2, the cloud was confirmed to have a high concentration of a chemical called ethyl formate, which is the same chemical that gives strawberries their flavor and is recognized for smelling like rum. You'll also find a high concentration of ethyl alcohol, or ethanol, the same kind that we use to make alcoholic beverages. If we were to harvest the chocolate rum-smelling cloud, every person on Earth could have 300,000 pints of beer a day for about 1 billion years. Number 29. The downside is that you'll have to open your spacesuit to take a drink, and that's going to be an extremely unpleasant death. But despite what Total Recall and other Hollywood films tell you, death would not be instantaneous, but would occur over about a 2-minute period. That's not to say the 2 minutes would be pleasant. They'd probably be the most horrific thing you ever experience. Or at least it would be horrific if you didn't lose consciousness after around 10 seconds. After that, your blood would start to boil due to the low pressure of a vacuum, along with all of your other bodily fluids. This wouldn't kill you, but you would start to bloat up as the gas bubbles began to form throughout your body. You'd also be rapidly cooling and your eyes would freeze over. Death would finally come from a lack of oxygen. If you were somehow saved, you'd suffer damage to your lungs, eardrums, sinuses, and have soft tissue bleeding and bruising, depending on how long your rescuers took. Number 30. If the thought of death by boiling bodily fluids is a little heavy, it's not anywhere near as heavy as a neutron star, otherwise known as the remnant of a massive star that's burned through its fuel, undergone a supernova, and collapsed. If you were to take a single teaspoon of a neutron star, it would weigh approximately the same as the entire population of planet Earth. Or to be more specific, it would weigh around 1 trillion kilograms. Number 31. So let's now turn our attention to Venus, where a single day is longer than an entire year. Venus has the slowest rotation in the solar system, with a single orbit on its axis taking 243 Earth days. Complete rotation around the Sun, meanwhile, takes 225 Earth days, equaling a day longer than a year, at least if we're measuring by Earth standards. Number 32. Neptune, on the other hand, has completed only a single full rotation of the Sun since it was first discovered in 1846 by Johann Gottfried Galle. Since Neptune takes 165 years to complete a rotation, equaling a single year, again by Earth standards, it means that the planet finished its first rotation in 2011 and will complete its next in 2179. Number 33. Although Neptune should consider itself lucky that it has a sun to orbit around at all. It's estimated that there are around 200 billion rogue planets drifting through our galaxy that aren't attached to any star. Rogue planets occur when they're either ejected from their solar system via one celestial event or another, or if a planet forms independently from an accretion disk. Planet formation without an accretion disk can occur when small drifting clouds collapse to a point and then gradually gather more mass as the effect of their gravity likewise increases. Number 34. Developing rogue planets gain mass over time, but in contrast, our Sun is currently doing the exact opposite, losing around 1.3 trillion particles every second. Or to put it another way, the Sun continuously sheds around 1 billion kilograms per second every second, but don't worry too much, with a weight of around 2 nonillion kilograms, that's a 2 followed by 30 zeros, it won't be running out of weight to shed anytime soon. Number 35. And speaking of unusual characteristics of our sun, that it doesn't have a nearby companion is the exception, not the norm. There is a perception that all stars have solar systems similar to our own, but that isn't the case at all. More than half of the stars in the Milky Way are part of a binary or even triplet relationship, with multiple stars orbiting around a common center of mass. Red dwarfs, the smaller stars, generally don't have a companion such as our sun. Number 36. As lonely as the sun may be, it's probably far better off not having a companion, since companion stars are often vampires, otherwise known as cataclysmic variable stars. In this arrangement, the bigger star, normally a white dwarf, steals matter away from its companion or donor star via its overpowering gravity. Number 37. Interestingly, the greed of the vampire star is eventually its undoing, as there is a limit of mass that a white dwarf can support while still remaining stable. The upper threshold of supportable mass is referred to as the Chandrasekhar limit, and once exceeding this limit, the white dwarf explodes and is completely destroyed. Number 38. You would want to be around a white dwarf when it does explode, unless you want a serious suntan. Although, interestingly enough, distance from the sun doesn't always directly correlate to heat. You'd think that the planet farthest from the sun would be the coolest, Neptune. It turns out the coldest planet is Uranus. Uranus has an average temperature of minus 195 Celsius, and if you're wondering why it's the coldest planet, so's everyone else. The exact reasons for Uranus being so cold aren't fully understood, though unverified explanations point towards the planet having an unusual axis, sideways, and this relating to a collision that occurred at some point in the past. Number 39. If you think Uranus is cold, the average temperature of space is minus 270 Celsius, remaining fairly standard throughout, not including the warmed regions around stars. There is, however, a location called the Boomerang Nebula, about 5,000 light-years away. The Boomerang Nebula currently is listed as the coldest place in space, with a temperature of minus 272 Celsius. The additional cold is due to the rapid expansion of gas expelled by a central dying star. Number 40. On the other end of the spectrum from the coldest planet, Uranus is Venus, the other temperature conundrum of our solar system. Venus also isn't the closest to the sun, but it is the hottest by far, with an average temperature of 464 degrees Celsius. As opposed to Neptune, the reason for Venus being so hot isn't a mystery, with the explanation being a phrase we're all familiar with: greenhouse gases. Having a very thick atmosphere of mostly carbon dioxide, Venus retains much of the heat that it receives from the sun. Number 41. But even Venus is nothing compared to HD 18977-3b, otherwise known as Hot Jupiter. Spotted in 2005, located around 64.5 million light-years away in the constellation of Vulpecula, the exoplanet would appear bright blue if viewed through a telescope. Its surface is estimated to be around 1300 degrees Celsius, or so absurdly hot that the surface is believed to be continuously experiencing a rain of molten glass. Why molten glass? Well, that's because any dust, rock, or other space debris that dares enter the atmosphere is immediately melted. And if that doesn't sound hellish enough for you, Hot Jupiter is also predicted to have never-ending wind speeds that are in excess of 8,700 kilometers an hour. Number 42. As searing as Hot Jupiter is, it falls short of the temperature of the average star, though that isn't always the case. There is a variation of star that you could touch with your hand and feel warmth without scalding yourself, referred to as a Y-type or white dwarf. In this case, the temperature of the star ranges between 427 Celsius and minus 23 Celsius, with the circumstance being that these aren't technically stars, but rather stars that failed due to not having enough mass to sustain fusion. You obviously wouldn't really want to touch a white dwarf, despite it being cool, because it's still a gas giant, and if you recall, we established that you'd sink into it and die immediately. Number 43. If you're still wondering about Mercury, the closest planet to the Sun, it's a planet of extremes that marks the midpoint between Venus and Uranus. The daylight side of Mercury is a scorching 430 Celsius, the nighttime side minus 180, with an average of 167 Celsius. Number 44. Moving on from temperature, in 1054 CE, Chinese astronomers noted that there was a guest star in the sky that lingered for several weeks. There was uncertainty as to what the astronomers were seeing for centuries, until more recently it was discovered that the Crab Nebula exists in the exact same location as the guest star. This means that the Chinese astronomers witnessed a supernova, and the Crab Nebula is the remnants of that same supernova thousands of years later. Number 45. As bright as the supernova was, Lucy is brighter, at least in terms of human perception. 53 light-years from Earth is a star designated BPM 37093, located in the Centaurus constellation. Lucy was once similar to the Sun, but has matured into a smaller, carbon and oxygen-rich star. Based on observations, it's estimated that as much as 90% of the star's core may have solidified into a crystalline structure, otherwise known as diamond. If you were wondering, the name Lucy refers to the Beatles song Lucy in the Sky with Diamonds. Number 46. From pleasant diamonds to something truly terrifying. 250 million light-years away is the Great Attractor, one of the most bizarre, ongoing, unexplained mysteries. The Great Attractor is the central point of the Laniakea supercluster of galaxies, including the Milky Way, along with an additional 100,000 other galaxies. It's only known that the Great Attractor is having an enormous gravitational effect drawing galaxies in, but it isn't known what the Great Attractor is or why it's having such a profound effect. Number 47. A great deal scarier than the Great Attractor is coronal mass ejections, otherwise known as an ejection of magnetized plasma mass from the Sun. CMEs are associated with solar flares, are mostly unpredictable, and shoot off particles in a random direction at 250 to 3,000 kilometers per second. It's just a matter of chances as to whether Earth is in the line of fire. And the good news is that the effects aren't physically harmful. The bad news is that the particles are capable of knocking out electronics en masse, as was the case back in 1859, because number 48. A CME brought down most of the telegraphs in the US in 1859, gave telegraph operators shocks, and even started fires as telegraph machines sparked uncontrollably. This is what we now refer to as the Carrington event, and the extremely bright solar flare was witnessed around the world on September the 1st, with electronic disruptions peaking the following day. Number 49. In 2012, a powerful CME, now believed to be equal to the Carrington event, expelled particles at 3,000 kilometers per second and missed Earth by a matter of just 9 days. Had Earth been in the line of fire, we would have likely experienced blackouts for months or even years. Don't worry, you wouldn't know it based on the track record, but Carrington event CMEs are considered extremely rare, only thought to happen once every 500 to 2,400 years. Lesser CMEs, on the other hand, happen every 50 years, though wouldn't be powerful enough to cause widespread disruption. Number 50. CMEs can clearly be dangerous, but not as potentially dangerous as Oumuamua if it was indeed a passing alien spaceship. Oumuamua is the first interstellar object directly observed in our solar system back in 2017, attracting a great deal of attention for its peculiar characteristics. Observed to be cigar-shaped, small, and fast-moving, Oumuamua was closely observed for just 11 days, before moving beyond telescopic range. What made the object especially unusual is that it seemed to accelerate via unknown means. However, there are other logical explanations rather than it being an alien spaceship. You can get more details over at our Celestium channel if you'd like to know more, by the way. Number 51. Speaking of aliens, NASA's Pioneer 10 and Pioneer 11 probes blasted off in the 1970s and were fitted with golden plaques in case they happened to be discovered by an alien race. Each plaque contains an engraving of our solar system, where our solar system is located in the Milky Way, and images of male and female humans, with the male figure holding up his hand in greeting. The plaques are the only entirely visual, genuine attempts by humanity to communicate with aliens. Number 52. Similarly, Voyager 1 and 2 each carry 12-inch gold-plated phonograph records containing various sounds and images from Earth. The Pioneer and Voyager missions, in particular, were chosen for these messages given the nature of the missions and that the probes will likely still be discoverable and the messages still legible for hundreds of millions or even billions of years into the future. Gold is especially durable given its non-reactive nature, meaning that it doesn't naturally degrade, tarnish, or rust and can survive almost indefinitely. Number 53. If you're wondering if any aliens will actually get our message, you may want to turn your attention to the now widely known Drake equation, or to be more precise, the modified Drake equation. Frank Drake originally developed his equation to predict the likelihood of aliens existing in the Milky Way, and if those aliens are capable of long-distance communication. What's lesser known is that his calculations weren't by any means meant to be definitive, and were, in fact, nothing more than a conversation starter at the first official SETI meeting. Drake's equation was based on the average rate of star formation, the fraction of stars with planets, the fraction of those planets that may support life, the fraction of life that may be intelligent, the fraction of intelligent life capable of creating detectable signs of life, and how long signs of intelligent life will take to reach Earth. He came to the conclusion that there are between 1,000 and 100 million planets with intelligent alien civilizations, and his predictions sent global media into a frenzy. Number 54. Since then, the modified Drake equation has drastically altered the original formula and inserted more up-to-date information. With the new formula, science is now coming to the conclusion that the real number is closer to just one nearby alien civilization, and even that is a bit of a dice roll. Number 55. But if aliens are so unlikely, what exactly are fast radio bursts? Another inexplicable phenomenon. Scientists have been picking up flashes of electromagnetic radiation, first detected in 2007. Since their initial discovery, similar radio bursts being detected near constantly, some repeating and others seemingly once off. The flashes currently have no accepted explanation, and some hypothesize that they may be related to distant alien activity. On the other hand, the flashes are similar to other activity identified from astral bodies like quasars and supernovas, and so are probably related to stars, with the most likely culprit being magnetars. A magnetar is a type of neutron star, and as fascinating as it isn't an alien civilization, is it? Number 56. The Helix Nebula, designated NGC 7293 or Caldwell 63, is a planetary nebula in the constellation of Aquarius, and it looks so alarmingly like a giant eye that it's often referred to as the Eye of God or the Eye of Sauron. Number 57. Not shaped like an eye, but still incredibly unusual, is a supermassive black hole spotted by the Hubble Space Telescope in 2017. Near the galaxy 3C186, the black hole is around 5,000 light-years away, and it's particularly unusual because it's roaming through space unattached to a parent galaxy. Current estimates say it's traveled around 35,000 light-years at a speed of around 7.5 million kilometers per second. Number 58. Not nearly as daunting, but still a record, is Comet C 2014 UN 271, spotted in March 2022. The new comet measures around 137 kilometers across, making it 12 times larger than Halley's Comet and twice as big as the previous record holder, C 2002 VG94. The new record holder will be passing by Earth in January 2031, and at its closest distance will be around the same distance as Saturn. The comet won't be visible to the naked eye, but will be within range of larger telescopes. Number 59. If you already have your telescope ready and were hoping to see Halley's Comet, it was last visible in 1986, and congratulations if you were around to witness it, because it won't be visible again until 2061. Number 60. "2061 is a long wait, but there's plenty to see in the sky in the meantime. Alarmingly, there won't always be something to see in the sky from Earth, since one day the sky from Earth will be entirely featureless. As the universe expands and galaxies are pulled further apart, all signs of the Big Bang and points of reference will become non-existent. The stars will also eventually burn out, and all life, whatever life may or may not exist at that point, will cease to exist. Don't worry, this will take somewhere around 1,000 trillion years, so nothing to be concerned about just yet." Number 61. Something that is an immediate worry is getting a drink of water on the International Space Station. In order to save weight and simplify logistics, astronauts must drink recycled urine and sweat, which is a common practice in such extreme conditions. Scott Kelly spent a year on the ISS, and in that time is estimated to have drunk around 720 liters of recycled bodily fluids. Number 62. If drinking his own sweat made Kelly want to shed a tear, that tear wouldn't have run down his cheek. The limited gravity on the ISS means that tears gather around the eye like a coagulating jelly, and if not wanting to be partially blinded, astronauts have to clear any fluid from their eyes manually, and I guess they'd later drink that fluid. Number 63. Astronauts only travel outside the ISS on rare occasions, and when they do, they make use of a spacesuit or extravehicular mobility unit. Assumptions are that EMUs must be hyper-advanced in this day and age, but in reality, they're still based on a design from 1974 that's been modified only once, in 1998. Those same EMUs are being used today, though they were intended only to have a 15-year lifespan. They're so old that they're becoming increasingly difficult to maintain, though new designs are currently in the works and are intended to be ready by the end of 2026. Number 64. The new EMUs are almost certainly going to be white, and this wasn't a decision made arbitrarily. The eye-catching orange suits that you may have seen are for takeoff and re-entry, and are referred to as Advanced Crew Escape Suits, or ACEs. They're orange because takeoff and re-entry is when astronauts are most likely to land up stranded due to an accident, and the orange makes them very visible to rescue teams. The EMU suits, those intended for astronauts on spacewalks, are white to best reflect the heat of the sun. Number 65. If the thought of being lost at sea makes an astronaut want to turn in for a nap, they'll be doing so strapped down in a specialized harness. If not secured, a human's limbs on the ISS flail around randomly, and not only does this look silly, it's a good way to get painful bruises. Number 66. Supercritical water refers to water that is compressed to 217 atmospheres and heated above 373 degrees Celsius. When mixed with organic material, the liquid-like gas burns with no flame. This technique is used on the ISS to dispose of waste. Number 67. When Scott Kelly returned to Earth after his year-long stint on the ISS, it turned out he was 2 inches taller than when he left. His gut bacteria were also significantly different, and even his gene expression had changed. He did eventually mostly return to normal after some time on Earth, but 7% of his gene expression was permanently impacted, relating to immune system, DNA repair, and bone formation. So, Kelly was no longer the twin of his identical twin. Number 68. If that's the result of being on the ISS for a year, imagine the long-term impact on pioneers that attempt to colonize a foreign planet. Gliese 581G, 20 light-years from Earth, was announced in 2010 and is thought of as the best possible candidate for human colonization. The exoplanet is in orbit around a red dwarf named Gliese and is believed to exist in the habitable Goldilocks zone. Even still, it would be a considerable feat living on the planet, with temperatures ranging between -37 and 11 degrees Celsius. Importantly, there is a good chance that water exists on the surface and that it's liquid, even if below the surface. Number 69. It's fairly commonly known that space is completely silent given the lack of atmosphere for sound waves to travel through. But this isn't always the case, with some regions having clouds of dense, hot gas which are so thick that they act similarly to atmospheres, allowing for limited sound propagation. Number 70. We may not be able to hear it, but there is a constant symphony of noise happening in space at all times, observed by the scientific method of astroseismology. Tiny periodic changes in a star's brightness, plus movements on the surface, are converted via a mathematical technique called the Fourier analysis, which translates the data into audible frequencies. It turns out that stars sound like hums, whistles, and various bell-like tones, at least when using this method. Number 71. Space also apparently has a distinct smell, reportedly burnt steak, hot metal, or welding fumes. Astronauts obviously aren't smelling space directly, but it's often reported that those who come back from spacewalks carry a very specific odor. The scent is caused by particles such as polycyclic aromatic hydrocarbons, which cling to the suit. Number 72. Earth is within the atmosphere of the Sun. The Sun's atmosphere, referred to as the Heliosphere, is so vast that it extends well beyond all the planets in its orbit. Without the Heliosphere, we'd all be in a great deal of trouble, given that it plays the important role of protecting us from cosmic radiation. Number 73. And if you think that's unnerving, consider that you're currently traveling around 1,670 kilometers per hour due to the Earth's rotation, assuming you're near the equator. That isn't the grand total. You can add an additional 30 kilometers per second for the speed of the Earth's orbit around the Sun. Number 74. And it makes you wonder how we ever get off the planet at all, but we certainly do, with there having been over 200 space missions conducted by NASA alone, equating to 430 total people having traveled into space. And if you include all missions by all countries, there have been 398 human spaceflight missions, and if you're including unmanned missions, well, the number's in the thousands now. Number 75. Of the total 430 people that have entered space, 19 have died during spaceflight missions, and just 3 died above the Kármán line. During the Soyuz 11 mission in 1971, the spacecraft depressurized, killing 3 Soviet astronauts. Number 76. The number of humans that have gone into space is impressive, but it's nothing in comparison to the number of animals. Including all scientific studies since the mid-20th century, thousands of animals have passed the Kármán line, including monkeys, dogs, cats, mice, fish, frogs, turtles, spiders, and many more. The most famous spacefaring animal is Laika, the first dog to orbit the Earth, who sadly died aboard Sputnik 2 due to overheating. Number 77. Laika's death was tragic, but she left a big mark, similar to the footprints on the moon. Made in 1969 by Neil Armstrong and Buzz Aldrin, estimates say that the footprints will likely stay as they are for tens of millions of years, if not longer. With no significant atmosphere of any kind to disturb them, from a human perspective, the footprints are more or less permanent. Number 78. One of our nearest galactic neighbors is the Andromeda Galaxy, and it's coming this way at around 110 kilometers a second. The gravity between the two galaxies is overcoming the expansion of the universe, and if things continue as they are, the Milky Way and the Andromeda galaxies will collide. Don't panic though, it's going to happen in about 3.75 billion years. Number 79. When the galaxies do collide, they'll likely bond together in a similar manner to how metal in space permanently bonds when touching. On Earth, metal is protected by a hard oxide layer due to the presence of oxygen. In space, there's no oxygen due to the vacuum, and so 2 pieces of the same metal bond permanently on an atomic level. Number 80. If you take all the mass of our solar system, 99.86% of the total is made up of the Sun, 3/4 hydrogen, and most of the rest helium. The Sun is around 1,047 times more massive than the next biggest object in the solar system, Jupiter. Number 81. Of the 0.14% of mass left over from the Sun, most of the rest, about 2/3, is taken up by Jupiter. What remains accounts for all the other planets as well as all the moons and asteroids. Number 82. That leftover mass accounts also for a volcano called Olympus Mons on Mars that may still be active. Olympus Mons is 600 kilometers wide, 21 kilometers high, and around 3 times the size of Mount Everest. As impressive as Olympus Mons is, the central peak of Rhea Silvia on the asteroid Vesta, mentioned earlier, is still taller at 22 kilometers. Number 83. You may have noticed that Earth and most other planets in the solar system have moons. In fact, they tend to have many moons, with Earth being an outlier with just one. Mercury and Venus, on the other hand, have no moons at all, which is directly tied to their distance from the Sun. The Sun's gravity has stripped all possibility of these planets having moons due to its much greater gravitational influence. Number 84. Meanwhile, Saturn is currently the king of moons, with 82, though this number hasn't been entirely confirmed, so it's more accurate to say that Saturn has 53 confirmed moons and 29 provisional moons that have still to be officially verified. If you're wondering how a moon can be unconfirmed, some natural satellites are so small and faint that it can be challenging to observe them on more than one occasion. Other unconfirmed moons are strongly expected to exist due to context clues, but haven't been directly observed. Number 85. In second place is Jupiter, also with 53 confirmed moons and 26 that are still to be confirmed. Number 86. Earth's largest moon is the 5th largest in the atmosphere, with the biggest being Ganymede, which orbits Jupiter. The second biggest is Titan, around Saturn, and in 3rd and 4th place are Callisto and Io, and also Jupiter. Number 87. None of the moons just listed hold a candle to Enceladus, the moon of Saturn, at least in terms of reflectivity. Enceladus is encased in an icy shell and as such reflects almost 100% of the light that hits it. This also means that it's an extremely cold moon with a surface temperature around minus 201 Celsius. Enceladus is the most reflective astral body in our solar system. Number 88. A moon can be elegant even when not reflective if given the right name. The moons of Uranus are all named after characters in Shakespearean plays or after characters in a poem by Alexander Pope. Uranus has just had another moon recently confirmed, by the way, and you can learn more about that on the channel Celestium. We mentioned it already. Number 89. Pluto has a moon called Charon, after the ferryman of Hades, and it's about half the size of Pluto itself. The two astral bodies are tidally locked, meaning that they always face one another with the same side. Number 90. You'll recall that Pluto was once a planet, but it's now classified as a dwarf planet. If you're wondering why the change was made, Pluto is one of 5 other dwarf planets in the solar system, including Ceres, Haumea, Makemake, and Eris, with Pluto being only the second biggest after Ceres. There's also a good chance we'll discover more dwarf planets in our solar system as technology advances. Number 91. Although the Sun is stable now as a yellow dwarf, in about 5 billion years, it will consume Earth and many of the other planets in the solar system. The Sun will eventually turn into a red giant, and at that stage its surface will likely reach the orbit of where Mars is today. Number 92. A sun of that size would certainly be something to witness firsthand, though technically you're only ever seeing the sun as it was 8 minutes and 20 seconds ago. The same is true for all the stars you're seeing in the sky, given that you're only seeing the light of those stars, not the stars themselves. Sirius, for example, is 8.6 light years away, which means that you're seeing light 8.6 years old, or what Sirius looked like at the time the light started its journey. Number 93. Sirius is part of our Milky Way galaxy, which, by the way, has a more recently discovered black hole at the center of it called Sagittarius A star. As it turns out, almost all of the galaxies that we've identified have supermassive black holes at their center, which tells us a lot about the formation of galaxies. Black holes are thought to be the catalysts for the formation of galaxies, and without them, the universe would be far less structured. Number 94. It's unlikely that we'll get anywhere near Sagittarius A star anytime soon, given that it's 26,000 light-years away, but we have at least partially visited every planet in the solar system via an uncrewed spacecraft, though there has been a focus on some planets more than others, with Uranus being the planet we know the least about. Uranus has been observed up close only once by Voyager 2 when it flew past the ice giant in 1986. NASA has now made it a priority to get a probe to Uranus as soon as possible, with the Uranus Orbiter Probe mission currently in development. It's gonna go probe Uranus. I'm such a child. Number 95. Speaking of the Voyager 1 and 2 probes, you'll remember we mentioned they were fitted with the golden plaques for potential communication with aliens. This is because, after launching in 1977, the probes have been operating for more than 40 years. They are the first man-made objects to pass the boundaries of our solar system, with Voyager 1 entering interstellar space in 2012 and Voyager 2 doing the same in 2018. Contact with both probes has been maintained, although Voyager 1 had a recent temporary blackout. Number 96. While it's incredible how far the Voyager probes have gone, some argue that they haven't technically left our solar system yet. If we define our solar system as the heliosphere, the sun's atmosphere, the probes won't be clear for another 14,000 to 28,000 years. Number 97. Some have even suggested that the probes have to pass the mythical Oort Cloud to truly pass into interstellar space, the Oort Cloud being a theoretical boundary that marks the furthest reaches of the Sun's significant gravity field. Although it has never been seen or officially confirmed to exist, the Oort Cloud is believed to be a shell of icy objects that surrounds our solar system and everything in it. The icy objects are believed to be around 100 kilometers in diameter. Number 98. The Oort Cloud's objects are relatively small in the grand scheme of things, but are still bigger than the largest man-made object in space, which of course brings us back to the ISS. Measuring 109 meters long, the ISS travels at 27,000 kilometers per hour, meaning that it orbits the Earth once every hour and a half. Number 99. If you can get your timing right, you can see the ISS orbiting using a commercial telescope. The ISS is most visible at dawn or dusk when it best reflects the sun's light, and you can determine exactly where it will be with information freely provided by NASA. You'll need to be fast though, it crosses the sky in about 6 minutes and is often only visible for a few of those minutes. And number 100. Last but not least, the company International Flavors and Fragrances, or IFF, got an overnight sensation rose aboard the Discovery space shuttle in 1998. The stated mission was to see if new scents would be produced and if the rose still emitted its scent in zero gravity. The rose did indeed emit a scent, and the company also declared that the journey critically altered the rose in interesting ways. The space rose was then sampled and commercialized, producing the perfume Zen. Zen is described as having floral, woody, and otherworldly spiritual notes. And yes, it's still available to this day. Thanks for watching.